Okay, take, I don't know what it is, but I've already started on this one a little bit. Let me just check this one over here. 42325. This is the trapping rainwater one, so this one should be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then here I just introduced another one for the sake of example, I guess. What can you do in a situation like this? I guess you just guess like the idea would just be then because you guarantee that the minimum water level is going to be at the minimum peak, height of the minimum peak. And then when you add the water back, you just need to ensure that you fill up any gaps there. So here it's just adding water normally. This will be of so what happens if you add it like this? It's like it's decreasing like this, but then it only comes up by 1. So 4, 8, 12, for example. There will be 2, 4, 4, so this will give you 10. You know, minus the it's kind of annoying. You're gonna have to figure out where the maximums are. Okay. So then I have potentially an idea. We can use a stack, maybe. Stack equals to this. Oh, but then what about like duplicates like this? Don't need to add it to the stack, and then so at this point it would be like this. Add this to the stack. Okay, so in the stack I need to be able to add the index of the height. Okay. So I have to keep track of index of peaks, and then now we need to figure out, well, where the heck the peaks even are. So, because as I'm looping through this normally, we do for I in range then height. We'll have to start from 1 then in this case. So I guess in order to make this work, it's like if we determine the height, we just do if the previous value is a greater height. So if height I is less than height I minus 1, we do this. Dot append the index I. What about for these situations in the middle? No, we don't need to. Okay. Okay, I guess maybe it would be better if we can figure out where the first starting index is. So we do maybe not actually. We'll just keep it like this. If the height is greater, else if the height is greater than the height at the previous level, we do greater than or yeah, so then what we can do is we can pop the value off the stack. Okay, I guess we can just do this then. So then else if the height is greater than or is strictly greater than the one before it, you can do stack dot so id x equals the stack -1. Like this. If the stack is greater than 0, then we can do this. Else, if the stack is just 0, we can just continue, because like in this case, for example, or in this case, for example, over here, this index I has a height which is greater than I minus 1. But if this was the start, then we won't have anything on the stack. Here, we won't have anything. So height I is greater than. If length is equal to 0, then what we can do is we can just append the stack and continue, because there's no way the rainwater would drop on. Else, if it was in a situation like this, for the first time height, oh man. We should do stack.append I minus 1. Otherwise, if the height is greater than I minus 1, okay, so here, we're using this as an example, it's greater, so we append it, and then we continue. Append it and we just continue. Else, we keep going, append it and continue. Else, if height I is greater than the previous height, like this over here, has to be strictly less. So here, if height I is less than, so we don't append this onto the stack. And then if height I is greater than or equal to the value next to it, pop itself onto the stack. Hmm. Keep a stack of 0. Maybe it'll make it a bit easier. If it's less than the previous value, oh, this is kind of difficult. Wait, hold on. Because with the first bar, I'm already having problems. Like, how can I keep track of the water level? If it's like decreasing, I push it. Like if I start at I equals to 1, if the previous value is greater than my current value, push the previous value. If the previous value is, push it onto the stack. If the previous value So, I mean, the only way in this I could see this working is if it's less than or equal to, then I can just push it onto the stack as normal. I can just push I minus 1. But if the current height is greater than I minus 1, so I would have had 1, 2, 3, 4, 5. My stack would look like 5 so far before I get to 3. But then what happens if, like, let's say I get into a situation where it looks like this? If height I is, I don't append it. Okay, so if height I is greater than or equal to the stack, assuming that the stack isn't 0, because if the stack is 0, then yeah, else you just don't do anything. If the stack is greater than 0, then okay, no, this should work. This should work. So if the stack is greater than 0, so right now with the formula, idea is we iterate through here. We would have added this one to the stack, 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 no, this one to the stack. So it will look like this right now. And then when we're over here, if the height is greater than I minus 1, which it is, then So while length stack is greater than 0, stack is greater than 0, we do idx is equal to stack negative 1, and then we do idx is less than if the high idx is greater than or equal to high I. This will be the breaking condition. So we do if high index is less than high I, this will be the other thing. Okay, so what we'll do is, because right now these are on the stack, and then 5, 2, 1, or technically what we have on the stack right now is we have 0, 1, 0, 1, 1, and 2, like this. So we'll pop 2 of the stack, we'll do this 1 here, we'll calculate the water that can be accumulated between them. Lowest height is equal, we'll keep track of the lowest height, which is going to be 0. We'll calculate how much water can actually be stored between the two. We'll calculate, how much water can be stored between the two. So lowest height is 0. While stack, we do idx is equal, so index, idx is equal to stack negative 1, which represents the index of the last peak, or last value, which is this one over here. So if it looks something like this, for example, the water that can be held, so here, we need to calculate, well, how much water can fit into here. Well, that's gonna take forever. Is there a, especially for larger value, is there a way I can calculate how much water can be held before I get up to this point? It will just be the difference between the indexes. And then minus any water between those indexes. So for example, if it was between these two, the amount of water that can be held, we can very easily calculate it by just doing height times the difference in the indexes. 0, 1, 2, 3, 4, 4 minus. How many numbers are in between them? So 4 minus 1 minus 1, which is 2, so 2 times 2. And then that will be it. But then, how do I remove all of the stuff in the middle? It just has to be minus the one block in the middle, I feel, right? So here it will just be, for example, 0, 1, 1, 2. We get up to this place, and then with the stack, we pop the index 2 off the stack. It has a height of 1, and then that has a height of 3, which means that the water that can be filled is going in between them is going to be 1 minus the height of the I minus 1. Amount of water that can be held is, so water is equal to height IDX plus equals to height IDX minus I minus 1, because here we're guaranteed that, well, everything before this point is going to be added. And then we can do and then for the next one, we can just keep on going. We can do the amount of water that can be added is going to be, it's going, not the height of it, it's going to be ID, it's going to be I minus IDX minus 1 multiplied by height of IDX. These will removed. This will be added on the stack. Okay, so if it was 0, we shouldn't be adding it onto the stack at all then. Does not equal to 0. Because if it was equal to 0, then it's going to be a bit of a problem. Now the maximum amount of water that can be added into this little sanctioned off area has to be, like, let's say if it looked like this. So these are the two conditions. I'm confusing myself so incredibly much with this. My god. Index of if the height at the previous index is greater than this height, we don't need to pop anything. No. We do less than, make it a bit easier for ourselves. Then the accumulated water would simply be the, and do water plus equals to the height of the index What's the height of the index going to be? It's going to be height IDX and then multiplied by I minus IDX minus 1. And then we also have to minus any thing in the middle. No, it's just going to be the height of IDX minus height of I minus 1 in this case. Cool. And then once that's done, we can actually pop it off the stack. We can do stack.pop to get it off. So let's just take a look at it in practice, I guess, with this one. So if height is less than this, it is, so we add this onto the stack. Height I is greater than, yeah. While length stack is greater than 0, we can just do height IDX, which is going to be 5. If 5 is less than the height at I, we just did that case. Otherwise, if the height is like this, we can do water plus equals the height at I minus any water in this IDX, but we just don't pop anything. Cool. So here we have, so onto the stack we'd have the index 0, height of the previous, if height I it is less than height I minus 1, which is 5, we enter this loop, water equals to 0, lowest height is equal to 0, while length stack is greater than or equal to 0. So the length stack has one thing. Get the height of it. If 5 is less than 2, if 5 is greater than or equal to 2, less than or equal to, yeah. If it's less than or equal to r, so if 5 is less than or equal, which it is, if 5 is greater than 2, then we can do water plus equals the height I, which is just 2, minus I minus 1, which is just how much water there is, which means that it's just 1. Cool. And then we keep on going, and then once that's done, we can do water count plus equals to water, and then we keep going. No, and once all of that is done, what we should do is we should push the current value onto the stack, right? So we figured out that there's going to be 1 drop of rainwater here. We're still on this current iteration. And then what if now, let's say, this happened here? Now if this happened, we should just yeah, the next iteration we do, well, if the height is greater than I, there's no need to we're gonna break out of it. Lowest height is equal to this. And then what do? We do the water is equal to the height of IDX. Height of IDX should push this onto the stack. So we do stack dot and I minus 1 real quick, and then we can begin this. Maybe that will make it a bit easier to do. For example, like this. We push this onto the stack. Okay, yeah, this will work, this will work. While length is greater than this index of the previous peak is this. If height, and then we do if height at this index is less than the current height. So we just basically, this part will just keep going until we reach the number that can't allow it to overflow. Start off this one. The water that will be contained would be height index it would be I minus idx minus 1 minus the lowest height, like this. So this way we can get it equal to 0, and then we do the lowest height is equal to pop, so the lowest height is equal to 1. Now in the next iteration we're like, okay, well if height idx, which is 2, is less than 3, which it isn't, less than or equal to, then the water would be plus equals to 0, 1, 2, 3 minus 1, so it will be 1 multiplied by 3 minus the lowest height, which is 2. Yeah, and then otherwise we do water has to do water plus equals 2, and then we do the similar formula. We do 1 minus idx minus 1 multiplied by, and in this case, because it's greater than, we multiply it by height of I minus lowest height. And after all that's done, we go to the next iteration. Yay, I am so ready for this to just absolutely fail. Minus 42, what happened? Oh man. How can I possibly get minus 42? What the heck? Well, let's just try with one of the test cases, I guess. So we have a situation like this. And then, well, the early return doesn't matter. We do lowest height is equal to 0. It's probably got something to do with the lowest height, honestly. Let's just see. So for I and this, if height I is less than I minus 1, which it is, and height I minus 1 doesn't equal to 0, so we add 1 to the stack. We add this. We add 1 to the stack. Now the next one, we do I is greater than I minus 1, yep. We append 0 to the stack first. Water equals to 0, while len is greater than 0, because we have two things in the stack right now. IDX would equal to 0 if height at IDX for this is less than or equal to the height of I, which is 2, then the water would be 2 minus 0, which would be 1. No, 2 minus 1 minus, which would be 0. So the water is 0, and then the lowest height equals stack pop, which is just 0 in this case. Now, we keep on going because the stack isn't empty yet. We can do index equals to 1, and then we do if the height of the IDX is less than or equal to the height of 1 I, which it is, then we do water is equal to 0, 1, 2, 0, 1, 2, 3. 3 minus 1, which is 1, multiplied by the height of the index, which is 1. 1 times 1 is 1. So then the water count would just be 1 in this case. Water count plus equals the water. Done, and then we can move on to the next iteration. Okay, so let me just actually test this specific case. This one doesn't pass. It gives me -1. Why does it give me -1? If I is greater than or equal to I minus 1 does not equal to 0. So in this case, 0 shouldn't even be pushed onto the stack anyways, because it's equal to 0, so screw that. Height 0, so then 1, this one should be pushed onto the stack. Yeah, the index being pushed on is 1. Here, the index being pushed on is 3, 4, 7, 8. Yeah, no, this works correctly then. Guess it must be something to do with this height, because I'm getting -1. That should not be happening. Let's take a look. So then once we do that, we move on to the next iteration. If height is greater than or equal to height I minus 1, so we can print height I minus 1 first. Let's just print these and see if I minus 0, 1, 2, and 3. And then the stack shouldn't be entered at all, even in this case. Yeah. And then the second one, why would the yeah, no, so it's being entered correctly, so 2 and 0. Stack append, yeah, sure. Now, while the stack is greater than 0, which at this point it would be, idx is equal to 0, so height, which is 0, is less than or equal to 2. Then the water plus equals to index 0, 1, 2, 3 minus 2, which is 0. And then the lowest height will equal to stack. So now we do if the lowest height is equal to stack.pop. Print lowest height and see what happens. Lowest height should just be 0. Let's print that 3 times. Lowest height. Print the stack when the height is equal to 2. Okay, so the indexes are correct. Index is equal to 2, so if higher index to 0 will be 0 is less than 2, the water, yeah, lowest height is equal to stack pop, and then here we do if idx is equal to if idx is equal to 2, then we do print lowest height, because once we've popped it, oh, it's because I need to do this. There we go. Oh wow, it actually passed. Oh my god. Okay, cool. Well, it only took like 3 hours to do. Alright. Oh, then, what's the complexity? Oh, okay, whatever, good enough.